Hey guys, this video is called How Does Speed Affect a Projectile's Range? We are looking at horizontal projectiles launched, straight out, not up, down. Okay? So this refers back to the penny investigation you did with, let's see if we have a bunch of pennies. Boom! You remember these, right? So, the first thing you looked into was if you launch a penny faster, will it go further? And you saw that if you launch them from the same height, as I kind of drew here on a desk, that they take the same amount of time to hit the ground. That was kind of a surprising result to some of you. But the one that's faster, it doesn't necessarily hit in the same spot. It actually goes a little further out, even though it hits the ground at the same time. So see, I draw a big DX here to say that the faster one had a larger range, and the slower one has a small DX to indicate it has a smaller range. And the dotted lines just show the path they take to get there. I even drew a big VX to say the velocity was faster, and a long line there, and a small VX to say this velocity was slower. So that then the two pennies are on the desk right there. So, yeah, I mean, a real-life example of this might be if you have two quarterbacks who throw a football, and they throw it from shoulder height, both of them. They're about the same height, and the faster they throw it, the further it goes out. Doesn't mean it takes more time to hit the ground. It just ends up using that time to go further if they throw it faster, okay? So faster goes further. Further in what direction? A further range. That's horizontally. Alright, range is an X type of distance. Alright. Now, on the back of that penny investigation, you looked into another question. Say the pennies went the same speed off the desk, and say one of them wasn't even on the desk. Say it was very close to the ground at a different height. Did that affect the time to the ground and the range? Well, something dropped from very high versus very close to the ground. The higher one, let's kind of write that. The higher penny took more time to hit the ground. Right? The higher you drop it from, the more time it would take to hit the ground. So coin A hit later than coin B. Now, did that affect its range, though? If they are launched with the same speed, so Vx is the same for each penny, and coin B, you can see, actually goes a shorter range than coin A, which has a bigger DX or a bigger range there. So because coin A has more time in the air, it has more time for its speed to make it go out further. This is kind of like if you took two paper airplanes and you threw one out the door of the first story of any building, and then you brought another paper airplane up to the top story and you threw it again, and it's like it's going to go further. It just has more time in the air to cover more distance. Alright? So height affects a projectile's range. It does, because of it takes more time for it to hit the ground. So higher up equals more range. Faster gets you more range. Higher gets you more range. Alright? Faster goes further range. Higher up gets you more range. That's, they're both direct relationships. The thing that speed doesn't affect, doesn't affect the time for a projectile hit the ground, and we know that. Alright? It can make it go further. If it's higher up, it can make it go further. But faster can't make it hit the ground any faster.